Hello everyone! Welcome to Synapse Sessions episode 2. Today we are going to be talking about how stress and anxiety are truly affecting you. I am your host, Isabella Lohr, once again. So, most people think of stress and anxiety as feelings, some as a disorder or a flaw. You feel stressed before a test, you feel anxious before a conversation when something feels out of your control. But biologically, stress and anxiety are not just emotions. They're full body processes that directly change how your central nervous system works. So today, I want to answer a simple question with surprisingly a complex answer. What effect do stress and anxiety actually have on the central nervous system? To understand that, we need to understand how the brain and spinal cord respond to threats, how that response is supposed to work, and what happens when it doesn't turn off. The central nervous system, or CNS, is made up of two main parts, the brain and the spinal cord. Together, they control everything we think, feel, remember, and do. The CNS processes information from your environment, decides what matters, and tells your body how to respond. It regulates movement, emotions, memory, attention, and automatic functions like heart rate and breathing. Stress and anxiety don't just affect your mood. They directly change how the CNS processes information and communicates with the rest of the body. So, stress is not automatically bad. In fact, stress exists because it helped humans survive. When your brain detects a threat, real or perceived, it activates the stress response. This process begins in the brain, specifically in a region called the amygdala, which is responsible for detecting danger. When the amygdala senses a threat, it sends a signal to the hypothalamus, which acts like a command center. The hypothalamus then activates the sympathetic nervous system, part of the central nervous system that prepares the body for action. This leads up to the release of stress hormones like adrenaline and cortisol. Heart rate increases, breathing speeds up, muscles tense, and attention narrows. According to the National Institute of Neurological Disorders and Stroke, this response is known as the fight or flight response, and it is designed to be short term. In a healthy system, once the threat is gone, the brain signals the body to calm down. Hormone levels drop, and the nervous system returns to baseline. That's how stress is supposed to work. The problem begins when stress doesn't turn off. Chronic stress means that the central nervous system stays activated for longer periods of time, even when there is no immediate danger. This is common in modern life, where stressors are psychological rather than physical. According to Harvard Medical School, repeated activation of the stress response causes structural and functional changes in the brain. One of the most affected areas is the hippocampus, which is responsible for memory and learning. High levels of cortisol over time can reduce hippocampal volume, making it harder to form new memories and retrieve existing ones. Another affected area is the prefrontal cortex, which controls decision-making, impulse control, and emotional regulation. Chronic stress reduces activity in this area, which makes it harder to think clearly, focus, and manage emotions. At the same time, the amygdala becomes more reactive. This means that the brain becomes better at detecting threats, but worse at calming itself down. In simple terms, chronic stress trains the brain to stay in survival mode. Anxiety is closely related to stress, but it's not exactly the same thing. Stress is typically a response to a specific trigger. Anxiety is more about anticipation. It's the nervous system reacting as if something bad might happen, even when there's no immediate threat. Neurologically, anxiety involves persistent activation of the same stress circuits. Brain imaging studies showed increased amygdala activity and decreased prefrontal cortex control in people with anxiety disorders. That is from Neuroanatomy Trends in Cognitive Sciences. This imbalance means that emotional reactions happen faster and stronger, while rational regulation happens slower. The central nervous system essentially becomes hypersensitive. This is why anxiety can cause physical symptoms like muscle tension, rapid heart rate, shortness of breath, stomach issues, and dizziness. These are not imagined symptoms. They are a result of a real nervous system activation. Stress and anxiety can also change the brain's chemical signaling. Neurotransmitters like serotonin, dopamine, and GABA play a major role in mood, calmness, motivation, and emotional balance. Chronic stress can disrupt these systems. Research published in Nature Reviews Neuroscience shows that prolonged stress reduces serotonin signaling, which is associated with increased anxiety and depressive symptoms. It also interferes with GABA, the brain's primary calming neurotransmitter. Without enough inhibitory signaling, the nervous system becomes overstimulated. This is why people under chronic stress often report racing thoughts, trouble sleeping, and constant tension. While most people focus on the brain, the spinal cord is also involved. Stress increases muscle tone through spinal motor neurons, which can lead to chronic pain, headaches, and jaw clenching. The spinal cord also carries stress-related signals that affect reflexes and posture. This is why people under anxiety often hold their bodies differently with raised shoulders or a rigid posture. The CNS doesn't separate mental stress from physical response. It treats them as the same thing. While stress and anxiety persists over months or years, they can cause long-term damage and changes into CNS functioning. According to the American Psychological Association, chronic stress is linked to impaired memory and concentration, increased risk of anxiety disorders, increased risk of depression, heightened pain sensitivity, and sleep disruption. These effects occur because the nervous system adapts to stress as its normal state. This is called allostatic load, which refers to the cumulative wear and tear on the body and brain caused by repeated stress responses. Understanding how stress and anxiety affect the central nervous system matters because it reframes the experience. Stress and anxiety are not signs of weakness. They are signs of a nervous system doing exactly what it evolved to do, just for too long. The CNS is adaptable. That's the problem and the solution. Just as chronic stress can rewire the brain toward fear and hypervigilance, reduced stress, therapy, sleep, and regulation techniques can help restore the balance and strengthen prefrontal control. So, what effect do stress and anxiety have on the nervous system? They increase emotional reactivity, reduce logical control, disrupt neurotransmitter balance, impair memory and learning, and keep the brain in a constant state of alert. Stress and anxiety changes how the central nervous system processes the world, and understanding that is the first step towards managing it. That's all for today, guys. Thank you for watching. Mwah.